Today's lesson is called Combine Like Terms and Solve One-Step Equations. All right, so before we start combining like terms and solving one-step equations, let's just talk about what a term is. And I have a term right here, 4x squared. And there are parts to it, so let's just talk about the parts of a the parts of a term. So we have the coefficient, we have the variable, and we have the exponent. And nothing is going to be added or subtracted to it. So which one of these is which part of this term is the coefficient? The 4, good job. Okay, so the 4 is the coefficient. All right, and then the variable, the variable is the letter. I hope this is review for you, but I'm still gonna say it all out. The variable is the letter or the base of the exponential term. So just the variable. And then the the exponent is gonna be the number that's raised. It's to the power of. It is that 2 in this case. All right, if you have questions or anything, let me know. And let's talk about what the coefficients, the variables, and the exponents are of each of the following. If you printed it out, this second one is not a -9. Could you change it to a -9 if you printed it? Because I want to use negatives in here too. Okay, so what would the coefficient be in 8c squared? Right, it's the 8. Very good. And the variable? It's a c. Good. And then our exponent is going to be the 2. So the next 3 numbers are -9x, y raised to the 8th power, and 2a squared b cubed. So what I want you to do is make this little chart and fill out that. And I'll fill it out also, but you do it and then check. All right? Pause the video and fill it out, and then come back to check your answers. All right, so how'd you do? Okay, so a couple of the ones I want to point out is when you don't have an exponent, if you don't have an exponent at all, if there is no exponent, it's always a 1. So the other common forgotten thing is if you don't have a number in front of your variable, then we always know that the coefficient of that is actually a 1, but we don't really have to write it. All right. Okay, so moving on, since we know what coefficients, variables, and exponents are, let's talk. Like terms are terms that have the same variable and the same exponent. So the same variable and the same exponent. Okay, so let's talk about some like terms. Are these like terms? 3x and x. Are those like terms? Notice that they have the same variables and they both don't have exponents. They have the same, no exponent. So they are like terms. Okay, what about 3y plus y squared? Are those like terms? Well, they do have the same variable, don't they?
Yes, but not the exponent.
Exactly, yes, but not the same exponent. These are not like terms. Okay, but are these like terms? 1/2 h squared plus 2h squared. Are these like terms?
Yes.
They sure are, because they both have h squareds, even though I wrote them differently. Okay, so yes. All right, so when we combine like terms, we're going to keep the variable and exponent the same. What do we combine? We're going to combine the coefficients. And keep the variable and the exponent the same. Okay, so this is where I should have put my 3x plus x. Okay, so this is 3x plus 4x. Can we combine these like terms? Well, they have a common variable and exponent, so yes. So we're going to keep those the same and just add the coefficients. All right, let's do another one. 13xy minus 9xy. So our x and y are both, that's xy in both terms. And now we just combine our coefficients. So I have 13 minus 9xy. I hope you're working ahead and you got 4xy. One more example of 12x to the third y squared minus 5x to the third y squared. Okay, so I have x and y, and then x to the third, y to the second, x to the third, y to the second. So yes, I have like terms. Like terms, check. That's LT, check. Okay, so I'm going to combine my coefficients, and then I keep the variables and exponents the same. 12 minus 5, 7. Now, if I'm doing my math real quick and I make a little error, you feel free to correct me. Okay. So now that we combine like terms, we know how to combine like terms, and then we're going to solve one-step equations. So to solve is finding the solution of the variable. Okay, so I'm just going to go to the next page here, and we'll do a couple examples. Let's look at 5g minus 2g equals 9. Why do we put g's and 9's together? But we do. So make sure your g has a curved bottom and the 9 stands up tall. All right, so we're going to combine like terms. And then we're going to isolate our variable by doing the inverse properties. So then do the inverse operations until variable is isolated. All right, so we have combined like terms. 5g and minus 2g, those are the same terms, so we have 3g equals 9. And now this 3 is multiplied by the g, so to undo that, we will divide by both sides by 3. Whatever we do to one side of the equation, we must do to the other side, and so we end up with g equals 3. I have negative 29 equals 8x plus 5. All right, so again, I'm going to combine like terms. Well, there aren't any, I don't see any like terms that are on the same side of the equation. All right, so I'm going to inverse operations until my variable is isolated. So first, I have 8x, and I have a plus 5 added to it. So what should I do first? Yes, we're going to subtract anything that's not attached to my x first. So we end up with 8x is equal to negative 34. And 29, 33, 1, 2, 3, 34. Okay, so 34. And then now I'm going to divide both sides by 8. And we get x is, I'm going to go to my calculator, is negative 17/4. If you want to do a decimal, so negative 4.25. And somebody told me that the answer was negative 4.25, and I told them what I got, and so everybody agreed it was my answer. No. Oh well. Okay, so we did the inverse operations until it was closed. So this was actually a two-step. It's kind of a two-step, not just a one-step equation. One more, m divided by 3 equals negative 5. So here we'll multiply both sides by 3, and we get m equals negative 15. So this was combining like terms and solving one-step equations.